Hello students, my name is Peter Oyewale. Now in this tutorial we're going to be taking a look at sequence and series. Now this is a scheme of the content which we're going to use for this tutorial. Now what is a sequence? A sequence is a list of numbers that follows a pattern or a rule. Each number in a sequence is called a term. For example, the natural numbers 1, 2, 3, 4, 5 is a sequence. And the rule of that sequence is that you add each one to each time. Now in the last frame, we have told you what a sequence is. Now we want to know what is a linear sequence. A linear sequence is an arithmetic progression in which the consecutive terms increase or decrease by adding or subtracting a constant. This constant is known as common difference. And I'm going to derive that particular formula for you now. Now take a look at your screen. Common difference is given by t subscript n minus t subscript n minus 1. Now consider the arithmetic progression below. 2, 4, 6, 8, 10, 12, full stop. Now 2 is our T1, 4 is our T2, 6 is our T3, 8 is our T4, down to 12, which is our T6. Now when n is equal to 2, our common difference will give us T2 minus 1, which is T1. Our T2 is 4 minus 2, our common difference will be 2. When D is 3, when our n is 3, our D will give us T3 minus T2. Our T3 is 6, our T2 is 4. It means our common difference will give us 2. Now, the nth term of an arithmetic progression. The nth term of an arithmetic progression is given by t subscript n is equal to a plus n minus 1 common difference. So you can see the Tn is our nth term, our a is the first term, d is common difference. Now, let's consider the arithmetic progression below. 1, 2, 3, 4, 5. 5 is our last term, which is also the same as our T5. Y1 is our T1, 2 is our T2, down to 4, which is our T4. Now, since our T1 is equal to A, which is equal to 1, our common difference is T2 minus T1, which will give us 2 minus 1, which is still 1. Our Tn will then give us A plus n minus 1 common difference. Now, Tn will give us 1 plus 5 minus 1 times common difference, which is 1. So this is equal to 1 plus 5 minus 1 is 4. 1 plus 4, that will give us 5. Okay, now in this section we're going to be taking a look at arithmetic mean. Arithmetic mean, because this is a particular stuff that we're going to be using in a lot of questions. So now let's consider the arithmetic progression A, B, C. Now, from the idea of common difference, you know that your common difference is our subsequent term minus the one preceding it. So it means that common difference here is Tn minus Tn subscript n minus 1. So if our n is 2, our common difference will give us T2 minus T1. While if our n is 3, our common difference will give us T3 minus T2. Now, using the first one, if D is equal to T2 minus T1, it means D is B minus A. Or if D is T3 minus T2, it means our D is C minus B. Now, since D is equal to B minus A and that same D is equal to C minus B, it means that B minus A is the same thing as C minus B. If you make B to a formula, you get 2B is equal to A plus C. Our B will give us A plus C over 2. This is the expression for arithmetic mean. Now we're going to be using the arithmetic mean for this particular question. Now, if x plus 4, 2x plus 8, 12 is an arithmetic mean, that is, they are consecutive terms of an arithmetic progression. So, using our expression for arithmetic mean, if this is our A, this is our B, this is our C, we know that our B is equal to A plus C over 2, which is our expression for our arithmetic mean. So it therefore means that 2x plus 8, which is our B, is equal to x plus 4 plus 12 divided by 2. Now you cross multiply, 4x plus 16 is equal to x plus 16. Now collect like terms, you have 3x is equal to 0. It means our x is 0. A geometric sequence is a sequence in which each term is obtained from the preceding term by multiplying or dividing by a constant factor. This constant factor is known as common ratio, and it is defined by the formula Tn over Tn minus 1. Now, let's just do a very quick example of what I mean by the common ratio. Now, let's consider the geometric progression 2, 4, 8, 16, 32. Now, this is our T1, 4 is our T2, down to our 32, which is our T5. Now, common ratio is Tn over Tn minus 1. When our n is 2, our common ratio gives us T2 over T2 minus 1, which is T1. That is 4 divided by 2, which is to give us 2. When our n is equal to 3, our common ratio will give us T3 over T2, and that will give us 8 divided by 4, which is still 2. We can use any other number as our n, provided the terms are given. The nth term of a geometric progression is given by T subscript n is equal to a times I raised by n minus 1. You can see those parameters represented on the screen. Now we have already illustrated the expression for our nth term. Now, look closely at what I'm about to illustrate on the board. If we have a geometric progression 2, 4, 8, 16, our T1, our T2, our T3, and our T4. Now, 16 is our nth term, which is still the same as our last term. But let's assume that we don't know our last term. Let's say we're trying to get it. Now, let's take n to be equal to 2. Our T2 will give us a times I raised by 2 minus 1. It means our T2 is AR. Now, our A is our first term, which is our T1, 2. Our common ratio is Tn over Tn minus 1. Now, which is T2 over T1. It means our R is equal to 4 divided by 2, which is to give us 2. Now, our T2 is A times R. Now look at it. Our A is 2. Our R is 2, which is to give us that same 4, which is our T2. So it means when our n is 3, that our T3 will give us AR square. That is 2 times 2 raised by 2. And 2 raised by 2 is 4. 2 times 4, that will give us 8. Now, same thing for if you find it for the geometric mean. Now, from what you can see on your screen, if x, y, z are consecutive terms of a geometric progression, now the middle term is going to be the square root of the product of the first and the third term. Now, look at this illustration I'm going to give you now. Now we are going to define a geometric progression, and we're going to find the geometric mean. Now let's take x, y, z to be consecutive terms of an geometric progression, which will be our T1, T2, and our T3. Now, common ratio is given by T subscript n divided by T subscript n minus 1. That is, when our n is 2, our common ratio will give us T2 over T1, which is y over x. Now, when our n is 3, our common ratio will give us That's T3 minus T3 divided by T2, which is Z over Y. Now, since R is equal to R is still the same common ratio, it means that our first area, which is Y over X, will be equal to the second area, which is Z over Y. Cross multiply Y times Y, that will give you Y squared is equal to X times Z, which is XZ. You find the square root of both sides, you get Y is equal to square root of XZ, which represent the expression I gave you before you started solving this question. Now, this expression represents your geometric mean. Unit 3. Now we're going to series. Now, a series is the sum of the terms of a sequence. This means that when we add the terms in any given sequence, it makes up a series. For example, we can have arithmetic series, which is, you see an example. We can also have geometric series. Now, a finite series can be classified into two, which is a finite and infinite. You just don't know that a finite series is a series that has an end. That is, it ends after a finite number, while an infinite series does not end. Now, example of a finite series is given, which is 1 plus 2 plus 3 down to 100. But an infinite series is something like 4 plus 8 plus 12 plus 16 plus ... that is continuing and continuing and continuing. That is when like an addition of 4. Now, we can also have we have some formulas in arithmetic progression. We have sum of an arithmetic progression, which is defined by those two formulas. Now, each of those formulas are used when depending on the parameters you are given in a question. Now, for example, let's find the sum of terms of an arithmetic progression. Let's write out the formula first, which are the two formulas. Sn is equal to n over 2 into 2a plus n minus 1 common difference, and Sn is equal to n over 2 into a plus l. Now, consider the arithmetic progression below 1, 2, 3, 4, 5. Now, for 1, 2, 3, 4, 5, for it to be a series, that will be 1 plus 2 plus 3 plus 4 plus 5. This is now an arithmetic series. Now, our sum of first 5 terms, that is, we want to add all the terms of that particular series to each other. Our n will be 5, which is the number of terms. Our a is the first term, 2 times 1, plus our n, which is 5 minus 1, times our common difference, 2 minus 1, 1, 3 minus 2, 1, 4 minus 3, 1, and so on. So S5 will give us 5 over 2 into 2 times 1, which is 2, plus 5 minus 1, which is 4, times 1, which is still 4. S5 will give us 5, 2 plus 4, that is 6, divided by 2, 3, 3 times 5, that will give us 15. So it means the sum of our first 5 terms will be equal to 15. Now, if our sum of first 5 terms equals 15, doing this manually, 1 plus 2, that is 3, 3 plus 3, 6 plus 4, 10, 10 plus 5, that will still give us 15. But the reason why we need formulas is that if we are dealing with higher numbers, we are going to need formulas. Now, let's use the second formula. If Sn is equal to n over 2 into a plus l. Now, this, when you use formulas like this, is when you know the first and the last term. Now, S5 will give us 5 over 2. Our first term is 1, our last term is 5. 1 plus 5, 6, divided by 2, 3, 3 times 5, and that will give us 15. Recurrence. A sequence may sometimes be defined as a relation between two or more consecutive terms. Such a relation is called recurrence relation. Once a time a recurrence relation is obtained, this can be obtained successively. Now, for example, given the example below, a sequence U1, U2, U3 is defined by the recurrence relation UN is equal to 3 plus 0.5 U. Now we are to find and also we are to prove that particular expression. Now, the first thing that we are going to do is that since we are given our u1 to be 10, our u2, now look at the number here, 3 plus 1 over 2. Now our n, we are using 2, it means our n is 2. That will be the u2, which is u2 minus 1, which is u1. Now that will give us 3 plus 1 over 2 times our u1, which is 10. 2 in 10, that is 5, plus 3, 8. It means that our u2 is 8. Now our u3, using the same idea, that will be 3 plus 1 over 2 times 3 minus 1, 2, so that will be u2. So this will give us 3 plus 1 over 2 times our u2, which is 8. Now 2 in 8, 4 plus 3, that will give us 7. Now for our u4 will give us 3 plus 1 over 2 times 1 over 2, into u3, which is 3 plus 1 over 2 times 7. Now 2 in 7, that is 3.5. 3.5 plus 3, that is 6.5, which is 6 number 1 over 2. Now our u5 will give us, that's 3 plus 1 over 2 times u4. Now this will give us 3 plus 1 over 2 times 6 number 1 over 2 is 13 over 2. 13 over 2, yeah. Now this will be equal to 2 times 2, that is 4. So that will give us 3 plus 13 over 4. Now 3 plus 13 over 4, that will give us a final answer of u5 to be. So we are going to get our u5 to be, if we find the LCM, that is 13 over 4 plus 3. So we are going to get our u5 to be 6 number 1 over 4. Now our u1 is 10, our u2 is 8, u3 is 7, u4 is 6 number 1 over 2, u5 is 6 number 1 over 4. Now welcome. Now we want to try the other parts of the question. Now since we have already gotten our u1 down to u5, and our u1 is 10 down to u5, which is 6 number 1 over 4. Now I want to show that 6 plus 4 into 1 over 2 raised by n minus 1 is an expression for the nth term for any of the term of that series, which of let's just say that recurrent series. Now for the first one, look at it. We want to find what will give us 10. Now you look at the power, is raised by n minus 1. We know that anything raised by 0 is what? 1. So it means that if we have 6 plus 4 times 1 over 2 raised by 0, 1 over 2 raised by 0 is 1. 1 times 4, that is 4, plus 6, which is 10. We have proved that. Now take a look at it. If you raise it to power of 1, 1 over 2 raised power of 1 is 1 over 2 times 4, which is 2. 2 plus 6, that will give us 8. Now same thing for third term. 6 plus 4 raised power 1 over 2 raised power 2. So that will give us 1 over 4 times 4, which is plus 6, which will give us 7. Same thing for our u4 and also for our u5. So we have successfully proved that un will give us 6 plus 4 raised by 1 over 2 raised by n minus 1, which is what the question says we do. Recurring decimal. Now recurring decimal is a particular topic we'll be doing right from primary school down to junior school and also in the senior level. Now for example, 1 over 3 will give us 0.33333. That is an example of a recurring decimal. Now let's take an example. We want to convert recurring decimals to fraction. In junior school, you will have been taught how to convert from fraction to recurring decimal. But in this particular question, we are going to convert from recurring decimal to a fraction. 0.45 dot dot simply means 0.45454545 and so on. Now, I'm going to be making use of two methods. There was one that was taught by Uncle T, and there's another which is the application of sequence and series to solve this kind of question. Now, empty the one, method 1, and also, let me first use method 1. Now, this method is very, very simple, and you have to pay attention. It's something that is very, very simple. Now, how we apply this method is that now 0.45 dot dot, you say that let an alphabet and a non-alphabet be equal to 0.45 dot dot. Now, if x is equal to 0.45 dot dot, let's call that equation 1. Now we multiply equation 1 by 100 because we have two digits repeating. Now, if we multiply x by 100, if you multiply x by 100, you are going to get 100x. Why if you multiply 0.45 to infinity, this is 0.45454545 and so on. If you multiply by 100, the first two digits after the decimal point will come to the whole number, which will be 45 points. Now 4545 to infinity, which is still 45 to infinity dot dot. Equation 2. Now we're going to subtract equation 1 from equation 2, that is equation 2 minus equation 1. 100x minus x, 99x, is equal to 45.45 to infinity minus 0.45 to infinity, 45. So our x will give us 45 over 99. 45 is 5 times 9. 99 is 9 times 11, so that will give us 5 over 11. Now we're going to apply the second method, which is application of sequence and series. Now if 0.45, let's write it in the full form. That's 0.45454545 to infinity. Now this is also the same thing as 0.45 plus 0.0045 plus 0.000045 down to infinity. Now this has formed a geometric series, and we want to find the sum of this series, which will give us our fraction. And we know that to find the sum of a geometric series that is not finite, we use sum to infinity. So let's find our common ratio first. 0.0045 over 0.45. We are going to get our R to be 0.0045 over 0.45 is 0.01. Now, since we have gotten our R to be 0.01, our sum to infinity is A over 1 minus R. Our A is 0.45 over 1 minus our R, 0.01, which is equal to 0.45 over 0.99. Now 45 over 99, that will still give us 5 over 11, which is another approach to solve. Now this question is a very simple question. Now we are given our first term of the arithmetic progression to be 3. It means that our A is equal to 3. Now we are given the common difference to be 4, and the sum of terms of the series of the progression to be 820. Now we are looking for the number of terms and the last term. Now our Sn is equal to n over 2 into 2a plus n minus 1 common difference. So our Sn, which is 820, is equal to n over 2 into 2 times 3 plus n minus 1 common difference, which is 4. So 820 times 2, that will give us n into 6 plus 4n minus 4. Now 820 times 2 will give us 1640 is equal to 6n plus 4n squared minus 4n. 1640 will then give us 4n squared minus plus 2n, so 4n squared plus 2n minus 1640 will be equal to 0. So our n, this is a quadratic equation. Now solving the quadratic equation, which you can use any method, you're going to get your n to be 20 or your n to be minus 41 over 2. Now we're going to take the positive value, which is n is equal to 20. Our Sn will give us n over 2 into a plus last term, because we want to find out the last term also. So 820 will give us 20 over 2 into our first term, which is 3, plus our last term. So 2 in 2010, 820 over 10, that is 82, is equal to 3 plus L. Our L gave us 82 minus 3, which is 79.
Now in this question we have to find the sum of the series which converges to infinity. Now this can be represented as 1 over 5 raised to power 1 plus 1 over 5 raised to power 2, because 25 is 5 raised to power 2, while 125 is 5 raised to power 3. Now our common ratio will give us 1 over 5 raised to power 2 divided by 1 over 5 raised to power 1. It means our common ratio is 1 over 5. Now, since we are finding the sum of the exponential sequence, we are going to find our sum to infinity, which is a over 1 minus r. Now, our a is 1 over 5 divided by 1 minus our r, which is 1 over 5. Now, this will give us 1 over 5 divided by 4 over 5. Now, when your division sign changes to multiplication, this will give us 1 over 5 times 5 over 4, which is still equivalent to 1 over 4. So this will be our sum to infinity, in which the series converges to. And in this question, we are told to evaluate the 10th term of the series 3 plus 9 plus 27 plus 81 plus ... Now 9 divided by 3, that is 3, 27 divided by 9, that is 3, it means it's a GP. So our common ratio will give us 9 divided by 3, which is 3. Now our 10th term will give us AR raised to 9. Our A is 3 times our R, which is 3 raised to 9. So this will give us 3 raised to 10 using our laws of indices. And using your calculator, 3 raised to 10 will give you 59049. So that will be final answer. Now in this question we are given parameters which we are to find value of A and R. Now we are giving you 1 to be minus 1, we are giving you 2 to be minus 5. Now if you look at that formula, let's say the representation for nth term, our un is equal to a plus n minus 1 common difference, which is an expression for an arithmetic progression. Now this is still kind of similar to the formula they gave us for our expression for our n term, which is a plus br. Now let's find the n term using ap normally. That will be minus 1 plus n minus 1. Our common difference will be minus 1 minus 5 minus minus 1, which is minus 4. So un will give us minus 1 plus minus 4n plus 4. Our un will then give us minus 1 plus 4, that is 3, minus 4n. So now we bring down the representation we're giving. Un is equal to a plus br. Now it means if we compare those two equations together, we're going to get our A to be 3 and our B to be, okay, we are looking for R, not B. So our B to be -4.
Okay, welcome to this particular question. Now we're still going to be using the same approaches we have been using since. And in this question, we are told to find the sum to which the series converges. Now we know that the series is a geometric progression, so we'll find the common ratio, which is given by -1/3. That is our T2 over our T1. Now we know that sum to infinity is given by A over 1 minus R. Our A is 1 over 1 minus our R is -1/3, so this will be +1/3. So 1 over 1 plus 1/3, that is 4/3. Reciprocal of 4/3 is 3/4. So that will be the answer to that question. Okay, now in this question we're given the first term and the last term of a geometric series are 3 and 768. Now our first term is 3 and our last term is 768. Now if the sum of the terms is -1533, find the common ratio. Now our R, that is what we are looking for. Now from our nth formula, Tn is given by AR raised by n minus 1. Our Tn is 768 divided by 3 times R raised by n minus 1. Now this R raised by n minus 1 is equal to 768 divided by 3, which is 256. Now our sum to infinity formula is given by our sum of a geometric progression is given by A into R raised by n minus 1 over R minus 1. Now, using lots of indices, this is the same thing as R raised by n times R raised by minus 1 is equal to 256. It means that R raised by n times 1 over R is equal to 256. Therefore, R raised by n is equal to 256 R and cross multiply. Now going back to our sum formula, our Sn is 1533 is equal to our A, which is 3, into R raised by n, which is now 256 R minus 1 over R minus 1. Now 153 and 1533, that is 511, is equal to, let's cross multiply, into R minus 1 is equal to 256 R minus 1. Now this 511 minus 511 is equal to 256 R minus 1. Now let's call it like terms. 511 R minus 256 R will give us 255 R. Minus 511 going to the other side is plus 511 minus 1, that is 510. Our R is 510 divided by 255. Our R is 2. Well, now welcome to this particular question. We are told to find the first term and the common ratio of the geometric series if the third term and the seventh term are 81 and 16 respectively. So our T3 and our T7, our T3 is 81, our T7 is 16. Now we know T3 to be AR squared is equal to 81, our T7 is AR6 equals 16. Now if you say equation 2 divided by equation 1, AR6 over AR squared will give us 16 over 81. R squared and R raised power 6, that is R raised power 4. 16 in 81, that is 4, 3 raised to power 2 raised power 4 over 3 raised power 4. Now this is the same thing as 2 over 3 raised power 4, it means our R is 2 over 3.
Now, when our r is 2 over 3, we can substitute it in any of the equations. If I'm using equation 1, ar squared is equal to 81. Our a times 2 over 3 raised to power 2 is equal to 81. It means a times 4 over 9 is equal to 81. Our a will then give us 81 times 9, which is 729 divided by 4. That will be the final answer to the question. Okay, welcome to this particular question. Now, the sum of the first 20 terms of an AP is 45, and the sum of the first 40 terms is 290. Find the first term and the common difference. Now, we are given S20 already to be 45, and we are given S40 to be 290. Now, we know that our Sn is n over 2 into 2a plus n minus 1d, so that is equal to 45. And we're also going to repeat the same formula. Our n is 20, that will be 20 over 2 into 2a plus 19d is equal to 45. Now this is 20 divided by 2, that's 10. 10 times 2a, that's 20a, plus 190d is equal to 45, equation 1. And now for equation 2, we are still using the same formula. N over 2 into 2a plus n minus 1 common difference is equal to 290. Now our n is 40, so this will give us 40 over 2 into 2a plus 40 minus 1 common difference is equal to 290. Now 40 over 2 is 20, so this will give us 20 times 2a, which is 40a, plus 40 over 2, that's 20. 20 times 39, that will give us 780d is equal to 290. Now if we divide through by 2, this will give us 20a plus 390d is equal to 145, equation 3. Now, since we have equation 1 and equation 3 and we have 20a to be a common term, we can eliminate 20a. So if we decide to subtract equation 1 from equation 3, 390d minus 190d, that will give us 200d is equal to 145 minus 45, 100. D will give us 100 over 200, which is what? 1 over 2. Now, when our d is equal to 1 over 2, we can substitute it in any of the equation. If we are using the equation 1, 20a plus 190d is equal to 45. Now our d is 1 over 2, 20a plus 190 divided by 2 is 95. Now 20a will be equal to 45 minus 95, which is minus 50. It means our a is minus 5 over 2, or minus 2.5. Now in this question, we have to find the formula for this particular series, or let's just leave it as a progression. Now we know that this is a geometric series, that is a geometric progression, 6 divided by 12, which is 1 over 12, which is our common ratio. Now in terms of an arithmetic progression, is ar raised to power n minus 1, and our a is 12, our r is 1 over 2 raised to power n minus 1. Now we're looking for the formula, so we'll just leave this in the simplified form. So this will give us 12 times 1 over 2 raised to power n times 1 over 2 raised to power minus 1, applying a lot of indices. Now this will give us 2 raised to power n is equal to 12 times 1 over 2 raised to power n times reciprocal of 1 over 2, which is 2. 12 times 2, that is 24, times 1 raised to power n, which is still 24, divided by 2 raised to power n.
Now in this question, we have to find what limit does the sequence converges to.
tending from infinity, which has an interval of 1. So now we have n squared plus 1 divided by 3n squared plus 4n squared plus 2. Now, as n tends to infinity, that's what we're looking for this particular expression. Now, the thing that we're going to do is that we're going to divide through by the term with the highest order. Now, the term with the highest order is n squared, so this will give us n squared over n squared plus 1 over n squared divided by 3n squared over n squared plus 4n over n squared plus 2 over n squared. Now, once we get here, we simplify further. Limit of n tends to infinity is 1 plus 1 over n squared over 3 plus 4 over n plus 2 over n squared. Now, we are going to substitute our n as infinity. That will give us 1 plus infinity squared over 3 plus 4 over infinity plus 2 over infinity squared. Now, when you divide through by infinity, you are going to get 0. So that is why it is 1 plus 0, 1, 3 plus 0, 3. Now, in this question, we're looking for the expression for the sum of terms of the arithmetic series 8, 12, 16, 20. Now, we know that sum of terms formula is given by n over 2 into 2a plus n minus 1 common difference. So our Sn is our n over 2 into 2 times our a is 8 plus n minus 1 times our common difference 12 minus 8, 16 minus 12, which is 4. Now our Sn will give us n over 2 into 2 times 8, that's 16 plus 4n minus 4. So Sn will give us n over 2 into 16 minus 4, that's 12 plus 4n. Now this is Sn is equal to n into 2 into 12, that's 6 plus 2n. Sn is equal to 6n plus 2n squared. Now we have to find the sum of all the odd numbers between 1 and 99. Now this is a very simple question, and if you don't actually know the formula or the formulas to solve questions like this, you might have issues. Now, to find the position, to know how many odd numbers we are actually going to have, you're going to use the formula n plus 1 over 2 position. So 99 plus 1 over 2, that is 100 over 2, which is 50. Now the formula for finding sum of odd numbers is equivalent to n squared. Because when we have 1 plus 3, that will give us 4. When you say 2 is power 2, that's 4. So 50 squared will give us 2,500. The sum of 1 plus 2, 1 plus 2 plus 3 is referred to as. Now this particular question, the answer is triangular numbers. When you say 1 plus 2, 1 plus 2 plus 3, the sum. Now we have to find the sum of the first 25 odd numbers. Now we have done a particular question like this, and I've given you that the formula is defined by n squared. So our sum of the first 25 numbers will be sum is equal to n squared, which is 25 squared. 25 raised by 2, that's 625. Now, this particular question, if the second term and the fourth term of an exponential function are 6 and 54, find the nth term. Now, the second term of an exponential function is 6, which is, and our fourth term is 54. Now, T2 is given by AR is equal to 6, T4 is given by AR is power 3 is equal to 54. So if we divide AR is power 3 divided by AR, that will give us 54 divided by 6. So this R squared is equal to 9, our R is equal to 3. Now, since we are looking for the nth term of an exponential sequence is given by AR is power n minus 1. Now we need to find our A from equation 1, which is AR is equal to 6. 8 times 3 will give us 6, our A will be 2. Now, since our A is 2, those will be 2 times our R, 3 is power n minus 1. 3 raised power n is equal to 2 times 3 raised power n times 3 raised power minus 1. Now we have to find the first term of a geometric progression. The first term of a geometric progression is 10 and the sum to infinity is 20. Now we have to find the common ratio. Now we'll just simply use the sum to infinity formula, which is a over 1 minus 0. Our sum to infinity is 20 is equal to 10 over 1 minus 0. Cross multiply, 20 minus 20r is equal to 10. So 20 minus 10 is equal to 20r. Our 10 is equal to 20r. Our r is 1 over 2. Now the first term of a GP is 4 while the sum to infinity is 20. Still like the similar question. Now we also use the sum to infinity formula. Our sum to infinity is a over 1 minus 0. So this is 20 is equal to 4 over 1 minus 0. 20 minus 20r is equal to 4. So this 20 minus 4 is equal to 20r. 20 minus 4, that's 16, is equal to 20r. Our r will give us 16 over 20, which is equivalent to 4 over 5. If the sixth term of an AP is 11 and the first term is 1, find common difference. So T6 is equal to 11, our A is equal to 1, we are looking for our common difference. So A plus 5D is equal to 11, our 1 plus 5D is equal to 11, 5D will give us 10, D will give us 2. Okay, in this particular question, the fourth term of the AP is 13. That is, A plus 3D is equal to 13. Why the 10th term is 31, that is, A plus 9D is equal to 31. Now we have to find the 21st term. Now, our 21st term will then give us, when you subtract equation 1 from equation 2, you get 6D is equal to 18, our D is equal to 3. Solving that simultaneous equation simultaneously. Substituting D to be 3 in any of the equation, you get your A to be equal to 13 minus 9, which is 4. Now, when our A is 4 and our D is 3, the 21st term will then be given by A plus 20D. Our T21 will give us 4 plus 20 times 3. T21 will then give us 4 plus 60, and that will give us 64. Now, the second term and the fourth term of the GP are 8 and 32 respectively, for to the sum of the first 4 terms. Now, T2 is equal to 8 and our T4 is equal to 32. Now, it's a geometric progression. It means our sum, we are looking for our sum of first 4 terms. It means our AR is equal to 8 and our AR raised power 3 is equal to 32. So AR raised power 3 divided by AR is equal to 32 divided by 8. R in R raised power 3, that's R squared, is equal to 4, our R is 2. So the sum of the first 4 terms. Now we can also find our A, which will be 4 when you substitute in equation 1. So the sum of first 4 terms will give us A over R raised power n minus 1 over R minus 1, since R is greater than 1. So our A is 4 into our R, which is 2 raised power the number of terms, 4 minus 1 over 2 minus 1. So 4 times 2 raised power 4, that's 16 minus 1, 15. So 4 times 15, that will give us 60. Now, to express the recurring decimal below as a fraction, I'm going to be using the opposite method. So if x is equal to 0.3311, 3 numbers are repeating, we multiply through by 1000. So 1000x will give us 331.331 to infinity. So I subtract equation 1 from equation 2. That will be 1000x minus x, which is 999x, is equal to 331. So our x will give us 331 divided by 999, which will be our answer. Now in this question, we ask how many times of the series 2 plus 3 plus 9 over 2 must be taken for the sum to exceed 30. Now let's assume that our R is let's assume that we want to find the sum, the number of times at which we're going to attain a sum of 30. Yes, let's assume that first. Now we know our R is 3 over 2 already, so Sn will give us A into R raised by n minus 1 over R minus 1. 30 is equal to our A, which is 2, into 1.5 raised to power n minus 1 over 1.5 minus 1, which is actually 0.5. Now, 30 over 2, which is 15, divided by 2 is equal to 1.5 raised by n minus 1. Because 1.5 minus 1 is 0.5. 0.5 times 15, that's why we go 15 over 2. So 15 over 2 is 7.5. 7.5 plus 1, that is 8.5. Let's take the log of both sides. Our n will be equal to, yes, that will be log. Our n will be equal to log 8.5 divided by log 1.5. Now this will give us, using your calculator, log 8.5 divided by log 1.5, that will give us our n will be equal to 5.2781. Now you know we took an assumption that our sum of tens to be 13. So the number of tens that will give us a sum that will exceed 30 must not be equal to 5. It means our n will be equal to 6. So that it will have Now in this question, we are to insert true arithmetic mean between 3 and 19. Now they're asking us that what is the sum of the linear function. Now let's assume we have a, b, c. That is three common a, common b, common c. That is, those are the three arithmetic mean we want to insert between 3 and 19. So what we're actually going to do is that when you calculate your sum of tens, which is given by the formula n over 2 into a plus l. Now this is 5 over 2 because we're going to have 5 terms. Our first term is 3, our last term is 19. So Sn will give us 5 over 2 times 3 plus 19, which is 22. Our Sn will give us 55. How many terms are there in the sequence of AP whose sum is 180? Sorry, whose sum of terms is 180? The first term is 4, and the last term is 26. Now we are looking for a value of n. Now the sum of terms formula is given by n over 2 into a plus l, when you know the first term and the last term. So 180 will give us n over 2 into our first term, which is 4, plus our last term, which is 26. Now this 180 is equal to n over 2 times 4 plus 26, which is 30. Now 30 and 180, that's 6, is equal to n over 2. It means our n is equal to 12. Now this question, we have to find value of a and b in the sequence 7 here of a, b, 4. If the first three terms are in an arithmetic sequence and the last three are in a geometric sequence. Now let me write out the terms first. 7.5, a, b, 4. Now those first three are in an arithmetic sequence. Let's just represent it as an AP. While the last three are in a geometric sequence, let's just represent it as a GP. Now, if the first three are in an arithmetic sequence, it means common difference will exist. That is, T2 minus T1 will be equal to T3 minus T2. So what that means is that A minus 7.5, that is 7.5, is equal to B minus A. Now it means 2A is equal to B, 2A minus B is equal to 7.5. Now if you make If you multiply it by 2, 4a minus 2b is equal to 15. 4a is equal to 15 plus 2b. You make 8 formula, 15 plus 2b divided by 4. Now let's do the same for the last three terms which are in a geometric progression. T2 over T1, b over a is equal to 4 over b. Now b squared is equal to 4a. It means b squared is equal to 4 times our a, which is 15, plus 2b over 4. So b squared will be equal to 15 plus 2b. 4 will cancel 4. B squared minus 2b minus 15 is equal to 0. Now what are the two numbers, and when you multiply them together you get minus 15. When you add them together you get minus 2. So solving that quadratic equation, you get your b to be equal to 5 and your b to be minus 3. So when your b is 5, your a will be equal to 15 plus 2 times 5 divided by 4, which is 15 plus 10, that's 25 over 4. Now when your b is minus 3, your a is 15 plus 2 times minus 3 divided by 4. That's 15 minus 6 divided by 4, which is 9 over 4. Now this question is still similar to the last question we did, so I'll just solve straight. So 25 over 4 minus x is equal to 5 minus 25 over 4. So 25 over 4 plus 25 over 4, that's 25 over 2 is equal to 5 plus x. Multiply 2 by 2, 25 is equal to 10 plus 2x. So x will give us 25 minus 10, which is 15, divided by 2. Our x is 15 over 2. Now 5 divided by 25 over 4 is equal to b over 5. It means 5 times 4 over 25 is equal to b over 5. Now 5 in 25, that's 5. Our b will be equal to 4. Okay, now our common difference is 5 minus 2, which is 3. Since we are doing it on arithmetic progression, our sum of 10 is n over 2 into 2a plus n minus 1 common difference. Now our Sn will give us, that is our S10, that will be 10 over 2 into 2 times 2 plus 10 minus 1 times common difference, which is 3. Now this 5 into 4 plus 9 times 3, our S10 will give us 5 into, 5 times 4 is 20, 9 times 15. So that will give us 20 plus 9 times 15, that will give us, that's 5, 4, that's 135. So our S10 will give us 155. Now let's find the geometric mean for consecutive term of x, y, z. Now we have given you the remark at the beginning of this tutorial course. The geometric mean will be y is equal to xz, square root of xz, which is our a. Now in this one we have to find the arithmetic mean for the consecutive terms x, y, z. So our arithmetic mean will be given by y is equal to x plus z over 2, which is our option B. Now in this question we have to find the geometric mean for the consecutive terms 2, 4, 8. Now our geometric mean will just be 2 times 8, which is 16, square root of 16, that's 4, which is still the middle term. So the correct answer will be 4, which is option B. Now in this one we have to find the arithmetic mean for the consecutive terms minus 3, 2, 7. So the answer will just be 2, that is minus 3 plus 7, which is 4, 4 divided by 2. So it means our answer is 2, option A. Now in this particular question, to what sum does the following series converges? So which is our sum to infinity? So that is a 1 over 1 minus 1 over 5, which is 1 over 6 over 5, and that will be 5 over 6, which is option B. Now the third term and the fourth term of an arithmetic sequence are 15 and 5. What is the first term and the common difference? Now you have to solve this question and you are supposed to get C, which is 35, minus 10. What is the first term and the common ratio of the geometric sequence whose third term and the seventh term are -1 and 81? So if you also solve this question correctly, you are supposed to get option A, -1/9, 3. What is the first term and the common difference of the arithmetic sequence whose third and seventh term are -1 and -81? Now in this particular question, since we are given the third term to be -1 and we are given the seventh term to be -81, now our third term is a plus 2 is equal to -1, our seventh term is a plus 6 is equal to -81. Now let's subtract equation 1 from equation 2. 6d minus 2 that's 4d, -81 minus -1, that's -80. It means our d is -20. Now from equation 1, a plus 2d is equal to -1, a plus 2 times -20 is equal to -1, a minus 40 is equal to -1. It means our a is equal to 40 minus 1, which is equal to 39. Now we have to express the recurring decimal 0.311 as a fraction in its lowest term. So I'm still going to use the simplify method. If x is equal to 0.31 to infinity, we call it equation 1. We'll multiply equation 1 by 100. That will be 100x is equal to 1.31 to infinity, equation 2. So subtract equation 1 from equation 2. That will be 100x minus x is equal to 31.31 to infinity minus 0.31 to infinity. So 100x minus x, that's 99x, is equal to 31. Our x is equal to 31/99. That will be our correct answer. Now in this one also, we're also using the same method. That is, express the recurring decimal 0.27 to infinity as a fraction in the lowest term. So take it to be equation 1. We multiply equation 1 by 100. 100x is equal to 27.27 to infinity. Equation 2. So equation 2 minus equation 1, that will give us 100x minus x, 99x is equal to 27. Our x is equal to 27/99. 27 is 3 times 9, 99 is 9 times 11, which will give us 3/11 as the fraction of the lowest term. Now the common ratio in the geometric progression log 2, log 4, log 16 is log 4 over log 2, which will give us 2. And that is option E. If the nth term of the sequence is given by -2 raised to the power 1 minus n, the fourth term of the sequence is, the correct answer is option D. And this is where we're going to stop this particular tutorial video. Now this is a summary of all the formulas and particular remarks you can have in sequence and series. Interesting. Stay blessed.